Alright guys, today we're going to talk about how you classify triangles. There's going to be some notes. They're the same notes that I put up the other day on the website that had the different points and lines and rays and stuff. If you go onto the back page of that, there's types of triangles here in the middle, and that's what we're going to be talking about today. So for starters, there are two ways to classify triangles. Okay, so we can classify triangles by their sides. So we can classify by side lengths, or we can classify by their angles. Okay. So again, it's a triangle. So there's three angles, three sides. I'm pretty sure you guys know what a triangle is at this point. Okay. So I'm going to go over these, but just to do your work, there is something you can refer to here. So let's start off by side lengths. Okay. Here's what it comes down to. You can have all sides the same, or all sides congruent, all sides the same length. You can have two sides congruent, or you can have no sides. Okay. Okay. So some examples of this: if all sides are congruent, it's going to be what we call an equilateral triangle. Equilateral. It looks like that. There is only one. All sides equal, we call that, all sides congruent, we call that equilateral. There is only one. It looks like this. This is an equilateral triangle. Typically, you will know that because it will say 1, 2, 3, like that, right? But important for us to know, because we know a little bit more, is that if all the sides are congruent, then we actually know that all of the angles are congruent as well, and they're going to be 60 degrees, 60 degrees, and 60 degrees always. We'll talk about the degrees tomorrow, okay? Now, if two sides are the same, we call that isosceles. I swear one day, that might be spelled right. I could be wrong, okay? If two sides are the same, we call it an isosceles triangle. Now, here's the thing. Technically, by a lot of standards, an equilateral triangle is an isosceles triangle, okay? So they've kind of made this a point of emphasis because everything that's true about an isosceles triangle is also going to be true about an equilateral triangle. So right here, what do you know? All the sides are congruent and all your angles are congruent. So let's take a look at what an isosceles triangle looks like. Now, isosceles triangles come in lots of different shapes and sizes. Now, I have to spell isosceles again, really? Now let's put it back. Isosceles. I gave up. Isosceles. Okay, and that's two sides are the same. Okay. Typically, they can come in lots of different shapes and sizes. They look typically like this. They can be tall and skinny. They can be short and fat, right? They don't have to be facing this way. They can be facing different directions, right? Like doesn't have to be facing that way. It could be facing this way. It could look something like this. But one thing is for sure in all isosceles triangles, okay, that at least two of your sides are the same. So these two sides are the same. 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 Okay. The extra nugget of information we know is that the angles diagonal from these two. We call these two sides the legs. We call this side the base. So this is the base. These are the legs. Your two base angles are also congruent. Okay. So across from this one is this angle. Across from this one is this angle. Okay. Across from this one is here. Across from this one's here. So these two base angles are also congruent. And that's why when we talk about an equilateral triangle, that's still kind of an isosceles triangle because that is still true, isn't it? Those two angles are also congruent. Okay? So it's important for us to recognize that if we see something like this, right? If they give you this and they tell you that these two angles are congruent, you also know, even though they didn't tell you anything about the sides, that this is an isosceles triangle. Okay, so if they give you the two base angles being congruent, that's enough to say this as well. All right. And the last one is a scalene. There's not really, we can say much about scalene except that all three sides are different lengths. Okay, there's not much else we could say other than it's not isosceles, okay? So these three sides being different lengths or something like that, okay? Your three sides are different lengths, and that's what makes it scalene. So if all three of your sides are different, in other words, no sides are congruent, we call that scalene. And there's not a whole lot we can say about scalene, okay? But two sides are isosceles, okay? But that being said, anything we know is true about an isosceles triangle is also going to be true about an equilateral triangle. Now, that's by sides. What if we classified by angles? Okay. We'll talk about this, but all triangles have a total of 180 degrees. We'll get to that next time, okay? What that gives us is we have three options. You can have three acute angles, right? Because it's possible for three acute numbers to add up to 180 degrees. You can have one right and two acute, right? Or you can have one obtuse and two acute, right? So we'll get into the logistics of this when we talk about this, but it's important to remember these are your three options, okay? So if you have three acute angles, we call that an acute triangle. It's pretty straightforward. If we have one right angle, we call that a right triangle. It's impossible to have two right angles, by the way. It's impossible to have two obtuse angles, right? We call this obtuse. So if you know these words, that's about it. So what are you looking for? An acute triangle has three acute angles, right? So it could be, that's acute. Something like that. That's an acute triangle, isn't it? Okay, those look like they're three acute angles, right? This is less than 90 right here. They don't have to be the same. This is less than 90, and this is less than 90, right? Okay, different symbol. Okay, so they don't have to be the same. That's a different thing. But important to note is that your equilateral triangle, right? Your equilateral triangle is also an acute triangle, right? So all three of these sides are the same. But what else do we know? That all three of those angles are less than 90 degrees, right? 60, 60, and 60. Some isosceles triangles, not all, but some are acute. So an acute isosceles triangle might look something like this, right? That's an acute angle. That's an acute angle. That's an acute angle. Obtuse triangles. So I'll get to right triangle in a second. But an obtuse. Okay, what are you looking for? You're looking for one angle that is obtuse. You're looking for one angle that is bigger than 90 degrees, right? So all you got to do is kind of connect the dots. That is a terrible looking triangle, okay? So again, if we wanted to, could it be isosceles? Sure. What if I gave you something like that? This is clearly one obtuse angle, right? And two smaller acute angles, right? And the last triangle we have is a right triangle. It's got one right angle. This one happens to be an isosceles right triangle, so it's right and it's isosceles, right? Is it possible to have a right triangle that is also equilateral? Okay, we'll get to that. You should remember that from doing the Pythagorean theorem. But they could also be kind of much longer here if you want to, right? So again, what are you looking for? You're just really looking for the following, right? Is there three acute angles? Yes, then it's an acute triangle. Is there one right angle? Then it's a right triangle. Is there one obtuse angle? Then it's an obtuse triangle. Okay, so if you're familiar with those three words, which you should be by now, this should be pretty straightforward. Okay, so again, please, pretty please, download this, keep this handy. Right next, I'll freeze the screen right here for a second. If you guys want to go ahead and take a picture of it, take a screenshot, that's fine. But let me know if you guys have any questions or any hard time with the work, and I will talk to you guys soon.